The coconut tree is often called the Kalpavriksha, the miracle tree, because every single part of it serves a purpose. From the humble husk comes a massive industrial ecosystem that has become a cornerstone of our regional economy. Tamil Nadu stands at the absolute center of this global market, with nearly 4,500 active enterprises generating an annual turnover of over 8,000 crores. Our state is the primary engine driving India's coir production. On the world stage, India commands a staggering 70% share of the entire coir export market, and more than half of that volume originates right here in Tamil Nadu. But even with this dominance, the industry sits on the edge of a new era. To bridge the gap between traditional methods and modern global standards, the government of Tamil Nadu established the Tamil Nadu Coir Business Development Corporation, or TANCOIR. Despite the massive scale of the coir industry, there is a fundamental gap in how we track production. Inside the factory, raw materials move in a continuous, heavy flow, yet our understanding of that flow is often delayed and disconnected. Currently, most facilities operate in a data blind spot. Input material is fed into the machinery without precise real-time measurement. We only truly see the results at the end of the day when the final output is weighed and recorded. This black box approach leaves too many questions unanswered. We aren't accounting for the critical variations in moisture content which can drastically change the weight of the raw husk, nor are we tracking the subtle material losses that happen during handling. To move the coir industry forward, we need to stop looking at the end of the day totals and start looking at the live pulse of the production line. To bridge the massive data gap in the coir industry, we developed the Smart Efficiency Monitoring System. Looking at the block diagram, we don't just measure the weight, we account for the variables that skew it. Using high precision load cells and a specialized moisture sensor based on the frequency shift method, we capture the exact state of the soaked coconut husk. These analog signals are conditioned through HX711 ADC amplifiers. We transitioned this technical blueprint into a functional mechanical prototype. To simulate an industrial conveyor belt, we constructed a frame using a durable PVC pipes, featuring a 1.5 foot custom roller integrated directly with the load cell assembly. In this demonstration, you can see the roller wrapped in a black conveyor style cloth to replicate the factory conditions. As we feed coconut shells across the system, the ESP32 microcontroller performs edge processing, calculating the weight instantly and displaying it on the local OLED screen. This provides the machine operator with immediate feedback. Simultaneously, the ESP32 acts as a gateway, using its integrated Wi-Fi to sync every gram of data to a Firebase real-time database. The true power of this system is realized in our web-based interface. Once a manager logs into the secure portal, they are greeted by the comprehensive live dashboard. We have designed this interface to provide a complete digital twin of the factory floor. The app features 4 primary data cards: live input weight, live output weight, moisture percentage, efficiency ratio, the most critical metric which is calculated automatically by the system. But we went a step further. Below the primary metrics, the app generates a dynamic efficiency graphs. These real-time visualizations allows managers to spot trends over hours or shift. By turning the raw sensor data into actionable insights, we have moved the coir industry from manual guesswork to a high-precision data-driven management system.